Hello, everyone. Welcome to A1 Tutor Live Class. Welcome to A1 Tutor Live Class, the mathematics class for today. All right, so we are going to be starting right away. So I believe you can hear me. Please, if you can hear me, kindly signify in the chat box. Okay, all right, Sabi Manuel, thanks for your response. So today we are starting a new topic. We are starting a new topic in mathematics. We've concluded the topic indices, logarithm, and solved yesterday. And today we are going to start with another topic entirely. All right, so I believe you can hear me, and as well you can see what I have on the screen. So today we are discussing about a topic in mathematics which has to do with collections of elements. Okay, so to introduce this, let's take an illustration. If we are asked to list out the days of the weeks, we have Monday, we have Tuesday, we have Wednesday, we have Thursday, we have Friday, we have Saturday, we have Sunday also. So this is the list of the days in the week, right? So this is a collection of days in the week. The collections of days in the week. We don't have more than this. Okay, so if you look at this list, it is well defined that we have 7 days in the week. We have 7 days in the week. Okay, so this serve as collections of, probably, let me say, an object. In this case, the objects are the days of the week. The days of the week. So this can serve as a set. It can serve as a set because a set is defined to be the collection of a well-defined object. A well-defined object. So a well-defined object, in this case, we are talking about the days in the week. If you also consider the month in the year, is also a well-defined object. If we consider the names of presidents in Africa, it is also a well-defined object. If you are to consider the states in Nigeria, it is also a well-defined object. So set is the collection of a well-defined object. Okay, set is the collection of a well-defined object. So let's define what set is. It says set is the collection of a well-defined object. Set is the collection of a well-defined object. So the object can be numbers, it can be what? Letters, it can be what? It can be other things. Okay, you know, I made mention of states in Nigeria is also a collection of well-defined objects. Okay, so it can be anything. So far it follows the criteria as a well-defined object, it is said to be a set. Okay, it is said to be a set. If I'm asking us to give me the set of, if I ask you to give me the set of vowels vowels in English language. The set of vowels in English language. What is going to be your response? The set of vowels in English language. What would that be? The collections of vowels in English language. I want your response in the chat box. The collections of what? Of vowels in English language. I'm expecting your response in the chat box. What would be the collection of vowels in English language? I'm waiting. What would be the collection of vowels in English language? So what I'm trying to ask is to give me the list of vowels we have in English language. The list of what vowels we have in English language. So of course, that's going to be A, E, I, O, and U. Okay, so that will serve as the collections of what? Vowels. The collections of what? Vowels in English language. So this also is a set. Okay, and take note, sets are always separated by a comma. A comma. Okay, sets are always separated by a comma. When you are writing out some sets, you have to separate each of your members by a comma. Okay. Also, we don't use a normal bracket, parenthesis like this. What we use is called a curly bracket. We use a curly bracket to represent a set. We do not use a square bracket. We do not use this. We use a curly bracket. A curly bracket is what we use to represent a set. Okay, so let's proceed to some terminologies in sets as a topic. Some terminologies in set as a topic. Okay, so if you are with me, please kindly signify. All right, so I believe the definition of a set is clear to us. We said set is the collection of all of a well-defined object. Set is the collection of a well-defined object. Okay, so let's proceed. We are going to consider some terminologies in sets because we need those knowledge to be able to solve questions on that set. So we are going to be considering, we talked about sets already, okay? We've defined sets and we cited an example that, let's say we have a universal set and we are talking about the vowels in English language. We said this is a what? A set because it is a well-defined object. Take note, sets are represented by curly brackets and also they are represented by this symbol. A universal set is represented by this symbol. So we are going to consider some definitions, okay? So the first one we are going to consider is called universal set. Universal set. What is a universal set? Okay, a universal set, this is the model. This is the model set from which other sets or other subsets from which other subsets emerge. From which other subsets what emerge. Okay, so we said universal set is the model set. The model set. Universal set is the model set from which other sets, other subsets what emerge. So that means Universal set is the set that give birth to other subsets. Okay, universal set is the set that give birth to other subsets, and that is why it is referred to as the mother set, and it is represented by the symbol U or this symbol. It is represented by this symbol or this symbol. So this represents universal set. It represents universal set. So the set from which other sets can be formed, or from the set from which other sets, other subsets can emerge, is said to be the universal set, and is also called the mother set. It's also called the mother set. Okay, let's consider an example. The set of numbers from 1 to 10, the set of numbers from 1 to 10, the set of numbers from 1 to 10. So the set of numbers from 1 to 10 also represents a universal set. The set of number from 1 to 10 represents a universal set. Okay, so if I'm going to write this, I'll use the symbol universal set equals to 1, universal set equals to 1, comma, 3, 4, 5, 6, 7, 8, and 9, then 10. So this is a universal set. And from this universal set, we can get other subsets. Okay, we can get other subsets. We can get other subsets. All right. So if I'm going to consider some subsets from this universal set, let's say another set, which is a subset A, is even numbers, from 1 to 10. All right, even numbers from 1 to 10. So what will be the even numbers from 1 to 10? Even numbers, we have 2, comma, we have 4, comma, we have 6, comma, we have 8, comma, and we have 10. So you can see that out of the universal set, we were able to get another subset. So the universal set gave birth to subset A. The universal set gave birth to subset A. Or I would say subset A emerged from the universal set. Subset A emerged from the universal set. What about if you are asked to get the odd numbers from 1 to 10? What are the odd numbers from 1 to 10? I want it in the chat box. You can start listing them in the chat box. The odd number from 1 to 10. Odd numbers from 1 to 10. Of course, we have 1, comma. What will be the next one? Odd numbers from 1 to 10. Waiting. You can just be listing it one after the other, so that will be more faster. I've listed 1, which is 1. Then the next one should be 3. Okay. So I've taken 1, I've taken 3. I'm waiting. What will be the next one? The next odd number. All right. The next odd number will be 5. So we have 5, comma. What will be the next again? The next odd number. I'm waiting for your response in the chat box. What will be the next odd number? I've mentioned 1, 3, and 5. So we still have more within 1 to 10. Odd numbers from 1 to 10. Okay, we still have also 7. 7 is an odd number, comma. Then we have 9. 9 is also an odd number. So you can see that out of the universal set again, we got another subset, which is subset what? B. So a universal set is a set that is referred to as the mother set and is the set that gives birth to other subsets. Okay, and that is why it is considered as the mother set. It's considered as the mother set. I believe that is clear to us. I believe universal set is clear to us, so we can proceed. If it is clear, please kindly react. Okay, so let's proceed. So we'll take another terminologies. I will rub off the board. So we've discussed about the universal set. Now, let's discuss about the singleted set. The singleted sets. What do you refer to as the singleted sets? Okay, we are going to have the definition. These are sets with single elements, or you say these are single element sets. These are single element sets, or these are sets with single elements. Okay, you should be able to understand what we talk when we talk about elements, what it means. If I have set A equals to 1, 2, then 3, 1 is an element, 2 is an element, 3 is an element. So each member in a given set is said to be an element. Each member in a given set is called an element. So a set that has only single element, that is just one element, is called a singleted set. It's called a singleted set. Okay, so let's cite an example for that. An example of singleted set, let's say we have A is X such that X is the president of Nigeria. Okay, an example of singleted set, X such that X is the president of Nigeria. Who is the president of Nigeria? Your response in the chat box. Who is the president of Nigeria as a nation? Waiting for your response in the chat box. Who is the president of Nigeria? I'm waiting for your response. Okay, His Excellency Bola Ahmed Tinubu. Okay, so with that response, thank you, Manuel. With that response, do we have two names? We have just only one name. So in the set, I'm going to have His Excellency. His Excellency. Okay, Bola Ahmed Tinubu. So we have just a name inside the set. That means we have just one element inside that set. And that is why it is called a singleted set. A set that contains only one element is said to be a singleted set. Okay, so this is a perfect example of a singleted set. Is that taken? If I also say a singleted set is an example of, let's take now a school, the name of the principal of a secondary school. Of course, we have just one principal in a secondary school. We don't have two. We have one principal. Okay, there's a difference between principal and vice principal. So I'm referring to a principal now. We just have one principal in a secondary school. So that is also an example of singleted set. An example of what? Singleted set. Okay, so now let's proceed. I believe that is clear to us, right? Okay, so we move on to the next terminologies that we want to treat. Let's drop the board. Okay, so now let's talk about what we call the null hypothesis, I mean the null set, sorry, the null set. Or we call it the empty set. The empty set. So what is the what is the null set or the empty set? A set that has no elements or a set that contains no elements is called an empty set. So this is a type of set this is a type of set that that contains no elements. Okay, no elements. So a set that contains no elements is said to be a null set or an empty set. Okay, and is represented by this symbol, or we use this. So a set that has no elements in it, that is empty. We have nothing in it, like what we have here. We have no element inside the set. So it is called a null set or an empty set. Okay, I hope that is clear to us. So let's move on to the next one. I'm going to clean the board. We'll move on to the next one. If you have questions, please, we can drop it in the chat box. So we are going to attend to it together. So we've talked about the null set, which is also known as the empty set. Now let's move to the subset. Subset. What do you understand by a subset? This is the child. Okay, this is the child or children. This is the child or children of a given universal set. Of a given universal set. Okay, e.g., if universal set equals to A, B, C, D, and A equals to A, B, C, and B equals to A, K, all right, C, then D. Now, universal set, we've talked about universal set, and we said another name for universal set is what? Response in the chat box. Another name for universal set is also what? Called what? We made mention of universal set as the first terminologies, and we said it is also called something. What do we call a universal set? We have another name for it. We call it what? a model set. Thank you, Sadu Emmanuel. A model set. All right. So if universal set is a model set, that means the subset will now be considered as a child. That is when you have just one subset, and or it can be considered as children. That means we have many subsets emerging from the universal set. Okay, so we said here that a subset, this is the child. That is when you have one subset, or children when you have many subsets of a given universal set. Of a given universal set. So we said that subsets emerge. They emerge from universal sets. Okay, so now if you are going to understand that very well, let's take a look at this example. Universal set is A, B, C, D. We have a subset here. Subset A is A, B, C. Subset B is A, K, C, D. Okay, so now looking at the universal sets and the two sets we have here, we have A in universal set, we have B in the universal set, we have C also in the universal set, which implies that A emerged, subset A emerged from the universal set. So subset A is a child to the mother set, which was the universal set in this question. So this is a subset. This is a subset of the universal set. So how do we represent subset? We have a symbol like this, subset. Okay, so I'm going to say A is a subset of universal set because A is a child to the mother set, which is the universal set. But let's consider the second one. Let's consider the second one. We have A here. We also have A here. We have K here. Do you have K in the universal set? No, we don't have K in the universal set. So which implies that already this K has violated the definition of subset. A subset is a set that emerged, okay, that emerged from the mother set, which is a universal set. So this guy, which is this K, has already violated the rule. So B is not a subset. That's why I have to cross it. Is not a subset of the universal set. So B is not a child, of the mother set. For this question we are considering, B is not a child of the mother set because of this K. Because in the universal set we don't have K. So it seems like this B is not a child. It does not belong to that mother. Okay, so B is not a subset of the universal set. Okay, now what about if I say we have C and C is given as A, B, and D? So I want to know your response. Is C a subset of the universal set? Just reply to me in the chat box. Is this set, which is C a subset of the universal set? Okay, yes. Okay, thank you, Sir Emmanuel, for your response. Yes, C is a subset. So we have C is a subset of the universal set. C is a subset of the universal set. I believe that is clear. So we'll move on to the next. We'll move on to the next terminologies. We have so many terminologies to discuss before we dive into some questions. Okay, so we need to understand the rudiment. We need to understand the foundation of this topic so we can be able to solve all questions that will come our way. Okay, so that is that about the universal set and the subsets. So can we proceed to the next? If yes, thumbs up. All right. Thanks for your response, Sadu Emmanuel. Okay, so move on to the next. We are going to be talking about the power set. Okay, the power set. the power set. So what do we call the power set? This is the collection. This is the collection. This is the collection of all the subsets of all the subsets of a given set. Okay, is denoted by 2 raised to power x. Is denoted by 2 raised to power x. Is denoted by 2 raised to power x. Okay, so we want to consider the power set. The power set is the collection of all the subsets in a given set. Okay, let me explain that with this example. Let's say universal set is given as 1, 2, then 3. Okay, 1, 2, 3. Okay, take note of that. Now, before I solve this question, I want you to put this down in your notes. Empty set is a subset of all sets. Empty set is a subset of all sets. Yes, the empty set is a subset of all sets. Okay, any set you are given, empty set will always be part of this subset. Okay, so you have to know that. So if you're asked to list out the subset of a given set, the first thing you need to list out is empty set. That is, when we have no elements, is also part of a subset. So I believe you have taken note of that inside your notes, so I can proceed. So if this is my universal set, and we want to get the collection of the subsets of this given set, which is 1, 2, 3, we have to use the formula that is given here. We said it is 2 raised to power s, where x represents the number of elements. All right, the number of elements. So in this case, I have 1, 1, 2, 3. So s is equal to 3. So if s equals to 3, I have 2 raised to power 3, and that is 8. That means I'm going to have 8 subsets in this universal set. I'm going to have 8 subsets. I'm going to have what? 8 subsets in this universal set. Okay, let's go. We are going to write out the subset now. Okay, the subsets are, now we want to list them out. What is the first subset I said we are going to write always when you are asked to write the subset of a given universal set? What is that subset? What is the first subset of all universal sets? I need your response in the chat box. What is the subset of all universal sets? Oh, the subset of all universal sets is the empty set. The empty set. Take note. The empty set. Okay. So if I'm going to list out the subset, I'll say the empty set first, comma. Now, I'll be picking this value to form some subset. We can have a subset that will have only one inside. That's a significant set, because it has one element, of course. Okay. We can also have a set that will have just 2 inside it. We can have a subset that will have 3 inside it. Do you agree with me? We can have a set that will have 1 and 2. So 1 and 2. Okay. We can have a set that will have 1 and 3. Okay. 1, 3. We can as well have a set that will have 2 and 3. 2 and 3, comma, 2 and 3. All right. And we can have a set that will have the 3 of it inside it. Okay. and that will be 1, 2, 3. Okay, if you count all this, it's going to amount to 8, because we said we are going to get 8 subsets. 1, 2, 3, 4, 5, 6, 7, then 8. So you can see we have 8 subsets. 8 subsets, as we have defined it here using the formula. 8 subsets. Okay, so I believe this power set is clear to us. Can we move on to the next one? Okay, so very quick one. Can you tell me how many subsets I'm going to have in this if universal set is equals to 1 alone? If universal set is equals to 1, okay, how many subsets am I going to have here? Just use the formula and tell me. That's very simple, actually. How many subsets? 2. Great. Great response, Emmanuel. We are going to have 2 subsets. 2 subsets, okay? Okay, can you mention those 2 subsets? What will be the first one and what will be the second one? What will be the first subset and what will be the second subset? Waiting for your response in the chat box. Okay, the first subset is going to be the empty set and 1. Awesome. Great response, Emmanuel. Okay, the subset is going to be the empty set and the set of what? 1. So those are the two subsets you are going to have for this question. Okay, so that means we can proceed to the next terminologies, and now we are going to consider equal sets. Equal sets. Okay, so we'll clean off the board. Now we'll pick up the next one, that is equal sets. Equal sets. So what is an equal set? 2 or more sets are said to be equal, okay, 2 or more sets are equal if they contain the same elements, comma, order of arrangement immaterial. That is, order of arrangement is immaterial. Full stop. Okay, to explain the terminologies equal set, we are going to consider this also. X is given as the set A, B, C, then D. Then we have Y is given as B, D, A, C, then D. Okay, then K is given as A, B, okay, C, D, E, F. All right, now we are talking about equal sets. Equal sets. 2 or more sets are said to be equal if they have or if they contain the same elements. If they contain the same elements. Same, take note of the word same elements. Okay, if they contain the same elements, is said to be an equal set. And we have order of arrangement is immaterial. That is, we do not consider the order of arrangements. The arrangement can be mixed up, but so far they contain the same elements, then it's said to be an equal set. Okay, it's said to be an equal set. Now consider X, B, X, Y, and K. Okay, let's consider X and Y. We have A here, right? We have A here. You can see the same elements. We have B here. We have B here. The same element, all right? We have C here. We have C here. The same element, all right? We have D here. We have D here. Okay, I know you'll be asking yourself, D is repeated here. Yes. Okay, is to tell us that even if D is repeated, D is still D, is not changing. So D here, the same thing as the D we have here. But in set, we are not allowed to repeat elements. Okay, we are not allowed to repeat elements. So what we have for Y can also be written like this. I can as well write the set Y as B, okay, D, A, C, okay. So I'm going to ignore this last one here because in a set, the elements are not expected to be repeated. So if I remove the D, it does not affect the set, okay. So if I have it this way, we could see that what we have here is exactly what we have in X, okay, is exactly what we have in X. So what do we say? We say X is equal. X is equal to what? Y. X is equal to Y. X is equal to Y. Okay, I believe you understand that. Is that clear to us? Okay, now I want to leave you with this. Tell me, is X and K, is X equal to K or not equal to K? Your response in the chat box. Consider X and K now. X and K. So what will be the X is not equals to K? Awesome response. X is not equals to K because we don't have E here. F also has made it not to be equal. All right. So S is not equal to K. Okay, what about Y and K? Y and K. Is Y and K equal or not equal? Waiting for your response. Not equal. Y also is not equals to K because they do not have the same elements. Underline that word, same elements. It is a must that they have the same elements. If they do not have the same elements, then they are not equal. Okay? So let's move on to the next one. The next terminology is equivalence set. Equivalence is different from equal. Okay, get it right. Equal, equivalent, they are totally different. Okay, so let's try to explain what equivalent also is all about. Equivalent sets. So we're going to rub the board. Now on to the next one, equivalent sets. All right. So what is equivalent set? Equivalent sets, two or more sets, two or more sets are equivalent. Two or more sets are equivalent when, okay, when they contain, when they contain equal elements. Equal elements. So this equal elements here is talking about the numbers of elements in it. When they contain equal elements, it's said to be an equivalent set. All right, so I'm going to cite an example. Set A equals to 1, 2, 3, then 4. Set B is equals to A, C, D, and E, and set C is equals to A, B, C, D, E, then F. Okay? Now, we are talking about equivalent sets now, and we said two or more sets are equivalent when they contain equal elements. So now we are dealing with elements. The numbers of elements will determine whether they are equivalent or not. So if I have this, how many elements do I have in set A? Can you tell me your response in the chat box? How many elements do we have in set A? How many elements do we have in set A? 4. Thank you for your response, Emmanuel. How many elements do we have in set B? In set B, how many elements do we have in set B? 4. Thanks for your response. 4 elements. And also in set C, how many elements do we have? In set C, how many elements do we have? 6. Thanks for your response. So now let's consider this now. Which of them has the same number of elements? Which set has the same number of elements? Which of the set has the same number of elements? Waiting. 2 or more sets. So it can be 2, it can be 3, it can be 4. So now, considering these 3 given subsets, which of the subsets has the same element? Can you state it in your chat box? I'm waiting. Which of the elements has the same number of elements? Okay, which of the set? Okay, A and B, right? A and B has 4, 4, which implies that A is equivalent. Take note, is not equals to now, but equivalent. Don't do mistake to write this. 3 lines. A is equivalent to B. Okay, A is equivalent to B, but A is not equivalent to what? C, and also B is not equivalent to what? C, because they have different number of elements. Different number of elements. All right. So I believe that is clear. If it's clear to us, please thumbs up. We'll move on to the next terminology. We'll move on to the next term. On that set, we are still treating some terminologies on that set. Okay, so let's move on to the next one. We call it cardinality of a set. Cardinality of a set. Cardinality of a set. Okay, permit me to clean the board. Cardinality of sets. Cardinality of set. All right, so let's consider what cardinality of set is. It refers to the number of elements, the number of elements in a given set. In a given set. Okay, say X equals to I, J, K, L. Okay, and if you ask to find the cardinality of set, it means the number of elements in that set is called the cardinality of the set. So it's represented by using small letter n in brackets S. So this is cardinality of set X. Cardinality of set X equals to the number of elements in set X. We have 1, 2, 3, 4. So we have 4. The cardinality of set X is what? 4. The cardinality of set X is what? 4. Okay? Is that clear to us? What is the cardinality of this set? Given that A equals to vowels alphabets in English, vowels. Yeah, given that A equals to vowels, set of vowels. So what will be the cardinality of A? 5. Awesome. A great response, Emmanuel. Thank you for your response, Sadu Emmanuel. 5. The cardinality will be 5. All right. So we move on to the next time. We move on to the next term, and we are going to consider the next thing to consider is union of a set. We have union of a set, we have intersection of a set, okay? Union and intersection of a set. All right, so let's clean this. Union of a set. The union of two or more sets is the combination okay, sometimes we say joining of elements of sets of given set of sets without repetition. Very important to have that in your definition. Without repetition. Without repetition. So the joining of two sets, the joining of two or more sets, or the combinations of two or more sets without repetition is called union of a set or union of the given set. Okay, let's consider A set A equals to 1, 2, 3, 4, and set B is equals to 2, okay, 6, okay, 1, and 3. All right, so we are given these two sets and we want to obtain the union of the sets. It means we want to obtain the what? The combination, the joining, like married husband and wife coming together to form a union. Okay, so A and B coming together to form a union. All right, so and we said we are not to repeat any elements. Take note, no repetition is allowed. A union B, the symbol is like this, not like this. So you have to be careful when you're writing your symbol. This is universal set and this is union. So A union B is equals to the combination. So we start from probably the least number. The least number is 1. So I have 1, comma. So for the fact that I have 1 here, I have 1 here, I'm not going to say 1, comma 1. No, that is wrong. That is not correct. Okay. It has to be just 1. Okay, no repetition. So I have just 1. The next one will be 2, followed by 3, followed by 4, and followed by what? 6. So we have the combination of sets A and B to be as a union. 1, 2, 3, 4, 6. That is the union of A and B. That is the union of A and B. Okay, that's the union of A and B. So we are going to use this also to explain intersection of a set. Okay, intersection. So let me include that here. Intersection. So what is intersection? Intersection is the common element between two given sets. I'll write it here. The common elements, two sets are said to have intersection as a result of a set that contains only the common element. So intersection of a set is the common elements, the common elements, the common elements between two or more sets. Between two or more sets. The element that is found in A and also found in B is a common element. Okay, is found in A, is found in B, is said to be a common element. Okay, so if I'm going to consider this, what are the common elements in A and B? Okay, I need your response in the chat box. The first one is 1. We have 1 here. We have 1 here. So A, the symbol for intersection is this. A intersection B will now be equals to 1, comma. What is the next common element we have? Okay, we have 2, then 3. Thank you, Emmanuel, for your response. Sadu Emmanuel, that's great of you. The common element is 1, 2, 3. Okay, 1, 2, 3. These are the common elements. We have 2 also, and we have what? 3. These are the common elements. These are the common elements. All right. So this I explained what union is and what intersection is. Okay, that explain what union is and what intersection is. I believe that is clear to us. If it is clear to us, please kindly thumbs up. Give me your reaction in the chat box. All right. Okay. Very quickly, let's take an evaluation. This topic continues next week. We can't exhaust the topic today. So next week, we'll continue the topic. All right. We still have like few terminologies to still discuss, but that will be in our next class. All right. So very quickly, let's evaluate ourselves. Okay. Evaluation period. If set A equals to 1, 2, 3, set B equals to 4, 5, 6. What is A intersection B? What is A intersection B? What is A intersection B? I'm waiting for your response in the chat box. What is A intersection B? No intercept, okay? So what do we call that? What do we call that? Yes, I agree with you that it is no intercept. But what do we call that? It has a name. And we have discussed it among the terms we were discussing earlier. When we have no common elements, empty set, awesome. So it is called an empty set. Okay. What about if I change it and I said A equals to 1, 2, 3, and B equals to 2, 4, 5. What is A intersection B? What is A intersection B? 2. Great. So if A intersection B equals to 2, what type of set is A intersection B? If A intersection B is equals to the set 2, what type of set is that set? We've discussed it. I'm waiting for your response in the chat box. What type of set is that set? Yes, what type? Singleton set. Awesome, great response. It is a singleton set. A set that has only one element is called a singleton set. Okay, so we are going to stop here today, and next week we'll continue from where we stop. We have many evaluation questions to treat by next week, but we are going to round it up. We are going to round up the remaining terminologies we are having by next week. Then we'll dive into solving question. Thank you for your time. Please do not forget, if you want to become a pro in solving math question and you want to indeed ace your UTME score, I would suggest that you always practice what you have learned on A1 Tutor Live classes, okay? So you can practice by making use of CBT questions, which is available on our app, A1 Tutor app. Visit the A1 Tutor app and ensure you practice questions. And if peradventure you are closer to the answer, the app will supply you with explanations that will make it more easier for you to comprehend. Watch videos on sets. You check SS2 as a class, and you have the video of sets under that class. And for friends that were unable to join today's class, do well to tell them they do not need to panic. Just tell them to go on YouTube, search for A1 Tutor, and watch today's class on YouTube and learn smarter. Okay? So thank you for your time. See you next week. Ensure you are not missing any of our classes. Thank you and bye. See you next week.